Okay, we're doing part 8 from this book right here, Prevent and Reverse Hypertension by me, Pete Rogers. We're on this section here, number 5, causes of hypertension, lack of dietary fiber. So if you have lack of dietary fiber, you end up getting leaky gut, which means increased intestinal permeability. The gut's called the enteric tract, so the gut lining cells are called the enterocytes. Normally there's good gut bacteria in your bowel and your colon. And those good gut bacteria, they take the dietary fiber from the plant foods. There's no fiber in animal foods. And they convert the fiber into short-chain fatty acids, in particular butyrate, 4-carbon butyrate, like a butanoic acid. And the butyrate is used then by the enterocytes, the gut lining cells, to make tight junctions. So there'll be cells, and in between the cells, there'll be a tight junction so that nothing can pass across that. If you don't have the fiber, you get a gap in that space, and then bacterial endotoxins can get across that space. And the bacterial endotoxins are LPS, lipopolysaccharide here, for gram-negative bacteria endotoxin. LTA, lipoteichoic acid, is the endotoxin from gram-positive bacteria. And they cause distortion of the clotting protein in the blood called fibrinogen. There's something called secondary protein structure, which is like a alpha helix, normally like a slinky. They distort its shape and it becomes beta-pleated sheet, flat, like a deck of playing cards. And then the beta-pleated sheets, they bind to each other. They form hydrogen bonds with each other. And then you have a larger molecular weight. The larger the molecular weight in water, aqueous solution of the body, the more likely it is to precipitate. To precipitate in blood is to clot. So the bottom line is when you have leaky gut, you form more blood clots. And they're a special type of clot. This is called an amyloid transformation. It changed secondary protein structure from alpha helix to beta-pleated sheet. And it's a form of clotting that's more refractory to lysis, harder to dissolve these clots. So these clots, typically in the range of 2 to 100 microns in diameter, they float around the body and they can plug up small capillaries and arterioles. Okay, so that's called amyloid clotting, sometimes called fibrinoid clotting. Douglas Kell from England and Etheresia praetorius from South Africa did the most research on that. Okay, other things, that when you get leaky gut, you get more systemic inflammation. Because you're getting more bacteria, more bacterial endotoxins going in the blood, the white blood cells of your human body get activated, and you'll have more white blood cells in your blood. White blood cells, they're big. You know, typical capillary is only 5 microns in diameter. Red blood cells are a little bigger, 7 microns. But a white blood cell, the most common one's a neutrophil, polymorphonuclear leukocyte, same thing, and they're about 14 microns. So they're big. It's harder to push them through your capillaries. So that's also going to make blood pressure go up. And some of these neutrophils will connect to things that they're going to try to phagocytize. And when they're hyperactivated, as they sometimes become, they can form NETosis. NETosis means extracellular neutrophil traps. And they'll basically commit like harikari, suicide, kamikaze, where they open up their plasma membrane and release their inner contents. They commit suicide, literally. That can be done when they're trying to phagocytize something and they can't fully get around it. It could be tissue debris. They might think it's a fungus or something, but they try to get around it. And once they release their inner contents, it causes a very prothrombotic reaction, forming more clots in the blood, and that can raise blood pressure, and it can lead to local activation of platelets and other things and potentially clot off an artery. So these are all ways that leaky gut contributes to thicker blood, more clots, and higher risk of having a cardiovascular event, a stroke or heart attack. So here's the act of NETosis by a neutrophil opening up its plasma membrane and throwing its DNA out into the extracellular space. Also will throw its mitochondria into the extracellular space. And this is the source, the origin of some of these unusual autoantibodies one sees in autoimmune disease, like anticardiolipin antibody characteristic of lupus, SLE, systemic lupus erythematosus. Anti-double-stranded DNA antibody, same thing with lupus because its DNA has been thrown out. So these are some of the things that you will see. Anti-neutrophil cytoplasmic autoantibody, okay? A lot of things start going wrong when you eat high-fat diets and have leaky gut. Next thing we're going to talk about is iron overload. In the Western world, men tend to become iron overloaded in their 20s. Women, after they're postmenopausal, they stop menstruating in their like mid to late 50s or early 60s, and that means they become overloaded with iron. The reason they become overloaded with iron is because animal foods tend to be high in iron, especially like red meat, for example. And most processed foods, a lot of processed foods are fortified with iron. So they just they grind up iron and put it in there. So the person becomes iron overload. You don't want that. Our body has the capacity to store some iron. Intracellular, we have these molecules called ferritin that can bind to 4,500 particles of iron. And that's in the event that, we have blood loss, we can rapidly replenish our hemoglobin, the iron for our hemoglobin. But you don't want to be overloaded with iron, because iron, is described by Eugene Weinberg, PhD, is like a fire. You want a fire in your stove, to heat up food. You want a fire in your fireplace to heat you up, but you don't want fire anywhere else in your house, or it burns the place down. Same thing in the human body. You don't want free iron. Iron functions well in hemoglobin, functions well in enzymes, functions well as iron sulfur carrier proteins for electron transport in intermitochondrial membrane. But you don't want free iron in your blood, because it'll catalyze reactions called the Fenton reaction. You can remember that for Fe2 plus for ferrous. Fe is the beginning of Fenton. And these will go back and forth, but it's called ferrous redox cycling between Fe2 plus Fe3 plus. It's a transitional metal, and it has a variable valence, so it can give off electrons. And what that means is it can cause electrons to be released and given to the the fibrinogen clotting protein and distort its shape, leading to the same amyloid transformation we talked about a moment ago with regard to leaky gut and bacterial endotoxins, LPS and LTA. So what I'm saying is free iron makes your blood more prone to clotting. That's bad. You can get a sense of what your risk of free iron is by looking at your serum ferritin. The ideal serum ferritin level is about 30 to 80. Okay, for example, when I was young, I used to think like Popeye the Sailor Man, I'd be bigger and stronger if I ate more iron. So I would intentionally eat Raisin Bran cereal when I was a young athlete, because I thought, I need that extra iron to become stronger. But so when I got my iron levels, like about 10 years ago, they were higher than I wanted to be. They were in the normal range, but they were higher than I wanted to be. They weren't 30 to 80. So every time I go to draw blood, I have them pull off a couple extra tubes. So I'm gradually getting it down. Last time I checked it was around 110. So I've gotten it down pretty good. I want to get it down to, 50 to 80 or so, somewhere in that range. Okay, so anyways, that was, and that a lot of the famous blood atherosclerosis researchers, they actually donate blood. I don't like to donate blood, because you donate too much blood at once, you can get dizzy and stuff. But anyways, I hope you found that helpful.